possible. Earlier we had only Pentium 4, Pentium 5. It's a single core CPU, and now we have i5, i7, and we have the servers up to 80 cores, 100 cores CPUs. The size is same. Size is even reduced actually. I will give one clue. The size is even reduced. Earlier we had a bigger PCs and now we have smaller PCs. Even laptops has got a lot of memory and CPU. Have you ever thought how all this is, how it got upgraded to uh, this technology, and what is the secret behind this? I want all of you to have the feel of this. So I'm discussing this topic in the first class. So then we can move to C programming. If you have any clue, you can tell me. Otherwise, I will start informing about that. Okay, let me go to my slide. This is my first slide. So I jumped into slide number 19. There was a lot of things behind this. I'm jumping into slide number 19. So I want this class to be interactive. So have you ever had a lab? I think you had a basic electronics subject and you had gates, transistors, and all these things, right? The digital circuitous, full adder, half adder, and some circuits which are made up of gates. You had all these things, right?
Yes, sir.
Okay. So mm, uh, see, I think if you had adder means we verified the output already. In your lab you had already verified the outputs. It adds two binary numbers, uh, 2-bit or 4-bit adder, 2-bit adder. There are 8-bit adders, and there are bigger adders also. So it means it is doing some logic. It is adding something. It means it is performing some logic and it is giving the output. You are adding two numbers and it is giving some output. So uh, what I'm trying to tell you is a computer is made up of chips. I hope my screen is visible, right?
Yes, sir.
I'm trying to open the slideshow. I want to jump into slide number 19. Yeah, we were in this slide. Computer is made up of chips actually. A chip is made up of gates. Normally, there will be a lot of gates will be there in the chip. The the gates are made up of transistors. So the basic building block of a computer is a transistor. So a transistor is like a brick which constructs a house. So as many transistors you can keep in a smaller area, uh, you can build more logic in a smaller area. That's what I'm trying to tell you. So earlier in SSI, uh, in SSI, I'll come back to SSI. This is called as a small scale integration. In SSI, I would like to one second. I don't want to tell history more. I don't want to make the things boring. You will learn these things, information about these things in I think when you have the VLSA subject. I think it's in the final year. I think VLSA subject. See, a small scale earlier in 1960s, they had something called as a small scale integration. So they used to put 100 transistors on a chip and they used to manufacture the chip. But in 1970s and 1975, they used to put 3000 transistors on a chip and they used to manufacture it. And LSI is something like they used to put 3000 to 1 lakh transistors on a chip and they used to come up with a chip with 1 lakh transistors. It means, for example, I'm giving, so as many transistors as possible you put in a chip, you can build lot of logic. Like for example, with 100 transistors, you can build a 2-bit or 4-bit adder. But with 3000 transistors, you can build such kind of adders which may be 100 to 500 full adders on a chip. And in LSI, it's like you can build like 1000 to 5000 full adders on a chip. So in VLSI, they started integrating 1 lakh to 10 lakh transistors on a chip. Uh, and in ultra LSI, it's more than 1 million transistors on a chip. What's happening here? The transistor count is getting increased. Transistor count is getting increased. It doesn't mean that they're manufacturing a larger chip. In SSI, a chip was a small, and in or a lorry or something like that. See the same size chip, same size, or even the smaller size chip from SSI to ULSI or VLSI. They have this. They kept the same size chip, but they put lot of transistors inside a smaller area. So what happens here is, so lot of adders can be built, lot of multipliers, lot of dividers. What I'm trying to tell you, why I'm giving the adder example is, somebody want to join. Yeah. What I'm trying to tell you here is, they started putting more and more transistors in a smaller area, and they started building complex logics in a smaller area. It means they the size is same from SSI to VLSI. The chip size is same, but they're putting more and more transistors in a smaller area. MSI transistor size is much more reduced in MSI, and much more reduced in LSI, and much more reduced in VLSI. So they reduce the transistor size as much as possible, and finally, uh, finally they are able to put lot of transistors in a smaller area. I hope you are aware. Are you able to understand?
Yes, sir.
Okay. So what happened here is they started putting lot of logics in a smaller area. It means for a 128 MB RAM, it was taking around maybe 1 million transistors uh, on the same size. But today, they're manufacturing 16 GB to 32 GB of RAM. They're putting billions of transistors in the same area. They started reducing the size of the transistors. So earlier it was a 1 centimeter transistor. Now it is reduced to nanometer. You cannot see a transistor now. So in my next slide, this is what I'm trying to explain you here. The transistor side is, see, the computer is made up of chip, which is made up of gates, and gates are made up of transistors. So finally, the the CPU or the RAM are made up of transistors. You will come to know in final year subject called VLSI how a RAM cell 1 bit can be stored in a RAM. How what is the circuit of a 1 bit? Uh, if you want to store 1 bit information, I hope you are all aware of what is meant by bit and byte. 1 byte is 8 bits, and bit is the smallest element in the memory. And uh, KB, MB, GB, gigabits. I hope all of you are aware. So 1 bit, if you want to store 1 bit, it requires two transistors. Okay, it requires two transistors. So they reduce the size as much as possible. So now what happens is they are into, when I was using the CPU, when I was using the CPU uh, in 2009, 2010, it was around 60 nanometer and 100 nanometer chip. See, when you buy a mobile phone, when you see the processor is Snapdragon or MediaTek CPU, just see what technology they are using. Whether it's a 60 nanometer technology, whether it's a 60 nanometer technology, or 20 nanometer technology, or a 30 nanometer technology. See, the nanometer here, it refers to gate length. Gate, gate of the transistor uh, occupies more area than drain and collector. Okay, source and drain. In case of field effect transistor, they use field effect transistors. Uh, Rather than source and drain, gate takes longer length. They started manufacturing less gate transistors so that the transistors size can be reduced. So they started putting a lot of transistor in a smaller area, and finally building complex logic in a smaller area. This is how the This is all the technology development happens. This is all the technology development actually. See, along with the technology development, the programming also will get evolved. uh, okay. So here, that's what I'm trying to tell you here. Size of the transistor is proportional to the length of the gate. So as the gate length reduces, transistor size reduces, number of transistors per unit area increases. So intelligence density, I can also call it as the logic density increases, the density of the logic. So you can put more and more logic in a smaller area, so that in a small area I can put a lot of RAM, lot of memory, and I can put it on a mobile phone. So that's how the technology development happened. So this is the thing behind when it was in 2004, 2005. Uh, we had 128 RAM. Now the same size RAM comes up with 16 to 32 GB of RAM. The size is same. So I hope all of you have understood. So now, when you see a Snapdragon or something like that, they say a 60 nanometer chip, 20 nanometer chip, or a 10 nanometer chip. What they call it as a nanometer chip that constitutes the gate length. That refers to the gate length. Okay, they started manufacturing smaller transistors, and finally they came up with very good CPUs. This is all the history. Okay, so one second, I'm getting a call. Yeah. So how, see, now earlier we had you have a feel of it, right, from Pentium 4, Pentium 5 to i7 with 16 to 30 to 32 GB of RAM. So that's how the technology development happened from 1960s to 2023. So in the small scale integration, we had low end CPUs. In small scale integration, we had low end CPUs. So, for example, I will tell you, if you are doing an operation called a plus b is equal to c, what happens? See, the computer has to perform addition. It should not perform addition only. I'm giving an example. It performs computation. I took addition as the example because it's very simple. So a plus b is equal to c. Inputs are a and b. Output is c, and the operation is plus. So a code refers to inputs, outputs, and an operation. A code is nothing but input. It will have inputs. Any statement, it will have inputs, and it will give output and some operation. That's what is called as code. Here, the A and B are the input, C is the output, and the plus is the operation. Okay, I will explain you. I don't want to get into too much deep into this because you'll get confused. So earlier in a small scale integration, few small circuits were there, less number of transistors, and when it comes to VLSI, it does complex operation, and it grown from simple operations to complex operations. Okay, so in the small scale integration earlier, the programming language was also simple, but now since the CPU can support complex operations, the languages are also complex. Like earlier, you know what, I think you had a 8085 and 8086 lab, right? In your lab as part of academics.
Yes, sir.
So in 8085 and 8086, they're all old processors. They came in 1980s and 1970s. Okay, they support only assembly coding. We have to write assembly code and then give inputs, give outputs, declare the inputs and outputs, and finally uh, run the assembly, store the assembly code and run it, store the assembly code and run it. But these days, see, don't think of anything else. Today, i7 is a processor, and earlier 8085, 8086 are the processors.